Welcome to the third and final day of the introduction to the seed system toolbox. And today we're going to hear about integrated seed health models, the Cassava seed unit toolkit, and the seed regulatory framework analysis, and the sustainable early generation seed business analysis tool. So we're glad you could join us. And I think we're going to briefly run through the rules of the game one more time. So if we could cue those up so everybody can see them. It's the rules of the game are pretty much just like they were yesterday. So as soon as we get that queued up, your videos and your microphones are turned off. The session is being recorded, and you can post comments on chat, but please use the Q&A button for your questions. And we have simultaneous translation from English to Spanish and from English to French. Next, please. There we go. So for the questions and answers, you can write in a question anytime. You don't have to wait until the end of the presentation. You can write one early and get in at the head of the queue. So just use the Q&A feature at the bottom of the Zoom screen to leave your written question, please. And the presenter will answer those questions during the Q&A session. And most of our presenters have been good about also sending written answers to those questions that they didn't have time to answer. So I would like to introduce our first presenter, Jorge Andrade Piedra. He is a plant pathologist at SIP. He's also one of the three creators of the toolbox, along with Margaret McEwen and Corneal McKeenders. So, Jorge, take it away.
Okay, thank you very much, Jeff. So welcome, colleagues. This is the review for day 2, and also a little bit of discussion about the program for day 3. And I am part of this coordination team with Corneal McKeenders and Margaret McEwen, who are coordinating the efforts around the toolbox. So just a quick reminder, this is a representation of a seed value chain from plant genetic resources, breeding, early generation seed, decentralized multiplication, farmer and trader use, and markets and consumers. So one of the entry points for using the tools, for selecting the tools out of our toolbox, is using the seed value chain. So you can see here the 11 tools plus the framework plus the glossary that we have in the toolbox. And you can see that these tools span across different components of the seed value chain. So on day 1, we described 4 of the tools. We started with the multi-stakeholder framework, and you can see there that the framework actually covers the whole seed value chain. Also small and exploratory case studies in day 1, 4-square method also in day 1, means chain analysis in day 1. And then in day 2, we covered yesterday impact network analysis, seed tracker, seed tracing, and experimental options. And today we are going to cover the integrated seed health approaches and models. So it's about degeneration, about pests and diseases. Cassava seed unit toolkit from our colleagues from Context, seed regulatory framework analysis, and the sustainable early generation seed business analysis tool. So with this, we described all the tools from our toolbox. Another entry point for using our tools, for selecting the tools, is the project cycle. So here you can see that we are going to describe today number 4, the integrated seed health approaches and models. And you can see that this tool can be applied for problem identification, scoping and diagnostic, also for objective design and strategy, for monitoring and learning, scenario analysis. Seed regulatory framework analysis is the number 10. It also can be used for diagnostics, for objective design strategy, for monitoring and evaluation and learning. And then we have the Cassava seed unit toolkit that can be used, I understand, for objective design strategy and also for implementation. So one of the points that I want to describe or discuss a little bit with you is that we have these two entry points, right? The seed value chain and also the project cycle. But really, the main entry point for using the tools are the research and development questions that you may have around seed systems. So with this slide, what I want to is to emphasize the need of having a clear research or development question around seed systems, and also touch upon a little bit about the differences between these three tools that were described yesterday: seed tracing, impact network analysis, and seed tracker, because they are actually are complementary and are in a way similar. So you can see here some examples of questions that you can ask and you can answer using the seed tracing. How is a new variety spreading from farmer to farmer, for example, or how do men and women share seed in different ways? So you can see that seed tracing is a more descriptive tool, so you can describe how seed is moving around with farmers. Then we have impact network analysis, and the type of questions that we are covering with the INA, with impact network analysis, are a bit different. So you can see here a couple of examples. What types of interventions are likely to lead to wider adoption of a new variety, or what subsidies would benefit youth and women? So you can see that the impact network analysis is not really a descriptive tool, it's more for a scenario analysis. And then we have seed tracker, which is, I would say, is a more pragmatic tool, is an IT tool. So you can ask questions like, how can I register and get certification of my seed online? So it's really a hands-on tool for supporting the creation of formal seed systems. Another example is where and who are the seed producers, customers, varieties grown, volumes, and seed production fields. So with this slide, what I wanted to do is to emphasize the need of having a clear research or development question to select your tool, and then to quickly describe the differences on research questions or development questions that you can address with the tools that we covered yesterday: seed tracing, impact network analysis, and seed tracker. Also, just a quick reminder that we have a lot of documentation for our tools. You can go to this link, and for each of the tools, we have a description sheet, a user guide, case study, tool validation. We have a peer review publication, and also technical support available. So really, there is a lot of information that you can use, that you can access to implement any of these tools. And also the toolbox is a growing organism, I would say. So we have a new partner, Context, and they are going to describe one of the tools that will be part of the toolbox in the future. So welcome to our colleagues from Context. And then just to remind you that this is part of a more ambitious course on building capacities around seed systems using our toolbox. We are in workshop number 1, so we are finishing today with all the tools. The tools have been presented. But at the same time, we have 4 national teams that will use at least one of the tools in real life conditions. So for these teams, welcome to this to the last session of this webinar. And the idea is for you to select the tools, at least one of the tools that you may use in your conditions for field work. And then in October, we will have a wrap-up workshop. The teams will present and discuss the results of field work, and the teams also will prepare a report and a proposal. So you can see it's a very ambitious training course for using the tools. And eventually, we will have a training course also in 2022. So thank you very much for your attention. With this, I think we can start. Jeff, again, to reiterate that you have access to a lot of materials from our toolbox in the links that are provided here. Thank you, Jeff.
Thanks very much, Jorge. We're going to hear next from Karen Garrett. We met Karen earlier, She is the author of 2 of the tools in the toolbox. Karen is a professor at the University of Florida and a plant pathologist. So Karen, welcome back.
Hi, this is Karen Garrett, and I'll be presenting information about an integrated seed health approach and the seed health model that's designed to evaluate scenarios for an integrated seed health approach. So an integrated seed health approach is designed to combine effectively the different sorts of management options that are available for seed health. So quality seed purchases, ideally of disease-free seed or quality declared seed, use of disease-resistant varieties, and on-farm management strategies such as positive selection or vector management, etc. So the idea of the integrated seed health approach is to combine those in an effective way, and so that the system can benefit from all the combinations and the interactions between those management approaches. Then the seed health model is a tool for evaluating how these management components are likely to work together given the characteristics of a system. And so then this model can be used to ask questions like this example here. How many cycles can farmers save their own seed if they use resistant varieties? So if we understand seed degeneration and the process of seed degeneration, then we can start to understand how often farmers will need to purchase seed versus saving their own seed. So the seed health model can be used to evaluate seed health at a small scale, like a farm, or at a country or region as well. As long as we have the data to evaluate the different regions, we can consider any level with it. And the users for this sort of model output would include extension agents, grower groups, and then anyone who's working in seed intervention design and implementation, and then also seed businesses for thinking about strategies for producing healthy seed. So the output from the seed health model gives the likely outcomes based on what we know about a system from data or from expert opinion. What the likely outcomes are for different seed health management combinations. So we can ask what if questions about systems. So for example, what if people can buy more seed for the system? What if they can use varieties that are more resistant to disease? What if people can use more on-farm management, such as seed selection? And what if you have combinations of those different kinds of management? And so the audience then would be people who are considering the different kinds of managements available and how they can be applied to keep seed healthy in seed intervention projects. Can also be relevant to policy as well for thinking about, for example, what kind of quality declared standards there would need to be for seed. So the minimum sample size for the seed health model can vary. The model can be used just for hypothetical scenarios without any data collection, just based on questions about what would be expected to occur given assumptions about a system. And then when precise estimates are needed for a particular system, for example, for the stages of giving people advice about management, enough data would be needed to characterize the system. So how much data would be required would vary from one scenario to another, depending on how many different types of environments there are, how heterogeneous the environments are, and how broad the analysis needs to be across different types of environments and across different sorts of management scenarios that are practical as well. So the resources needed for using the seed health model. So here we're talking about if data are already in hand or there's a hypothetical scenario that's interesting to people. So there need to be at least one person doing this analysis, so that this person, maybe ideally more people to form a team, would be organizing the data available and defining the scenarios of interest. And then the equipment needed would be internet access to use the online model version. So seed health is available in an online model, and then it's also available in R for people who would want to do more detailed analyses. And so R is free, but then a computer would be needed to run the models. And in terms of expertise, at least one team member would need experience evaluating biological and agricultural models. So if they're using the online model, they wouldn't need to have R experience. But if they're using more detailed versions of the model, then at least one member of the team would need experience with R. So the seed health model could be used at any point in a seed system project. So when there are data or concepts that are available. So it could be used before a project to anticipate what kind of management would be needed in a particular scenario, or at other points to see whether the management options that are available seem to be sufficient for the system. So there could be several different approaches to using a seed health model. There could be a one-day exercise where an individual or a team, to providing a group perspective, would develop a scenario that they want to look at and evaluate the outcomes. So this would be the sort of one-day exercise would be most practical for a hypothetical scenario or a scenario where people are just defining different sorts of combinations of management that might be practical. So if it's necessary to estimate parameters for a more precise model, and if the data set is complicated, there are a lot of different scenarios, different environments, different varieties being considered, then that might take a researcher a few weeks to really organize that data, get good parameter estimates, and then use them in the model. And then if there are new variations needed on the existing code, that could take an experienced R programmer a few weeks to incorporate those new variations. So we've tried to make the code so it's flexible for a lot of kinds of scenarios that people might want. So you probably don't need to write new code or work with a team to write new code. Probably you can use the existing model, and then the question is just, do you want to use a simple scenario for learning about the system, or do you want to estimate parameters from a more complicated data set, which would take more time? So the steps in using the seed health model then. So first would be deciding on what questions are going to be asked. So that could be by an individual or by a group. Maybe it's most interesting if you have a group to help decide what different aspects of the system are most interesting. Then step 2, estimate model parameters from the existing data, or just define the hypothetical scenario that's interesting. And optional step 3 could be to collect new data related to seed health out of the field, which could require many months if you're looking at multiple seasons, or potentially also to collect new data related to farmers' management choices, which could be more efficient. And of course, there are other tools in the Tools for Seed Systems toolbox that could help with characterizing farmers' management choices. Step 4, so enter the parameter estimates or other scenario information in the simpler seed health model online, or do a more detailed analysis in R. So then step 5, with the output of the model, considering the questions, evaluate what the implications are of the output in terms of whether, for example, a specific management combination is likely to be sufficient for the particular scenario you're considering. And also consider potential follow-up analyses. Once you see the outcome of one analysis, it might stimulate questions for following up on that. Then step 6, summarize the results in a form useful for stakeholders, and then perhaps also prepare a report and or a journal article to summarize those for a broader community. So methods that can be combined with a seed health model. So a literature review can be used to get parameter estimates. Maybe there's very valuable information already available in publications that then you could use with the seed health model to see the implications of those estimates for seed degeneration and what kind of management is required. Biological studies in the field could be a source of new data, characterizing crops, pathogens, and field conditions and how they influence seed degeneration. There could be social studies in the field, so new data might be collected to characterize farmer decision-making about management choices, for example. And again, there are other tools in the Tools for Seed Systems toolbox that could be used to help inform that. So we can consider gender in the context of the seed health model. When we're looking at different types of management options, we can consider that in the context of gender in terms of whether gender influences access to management. So for example, does gender influence access to resistant varieties, options for seed selection, or options for purchasing clean or disease-free seed? And once we know about how gender influences that, we can use the seed health model to see what the implications of that are for disease and yield across time. So if we know about limitations in access to tools based on gender, we can use a seed health model to see what the logical implications are of that. So the limitations of the seed health model. So users of the seed health model may ultimately want to be able to provide recommendations about issues like frequency of seed purchase or other management choices. But a model like the seed health model is only as good as the data that are available for it. So people might want to be able to make those kinds of recommendations before they actually have all the data available that they would need to be able to make recommendations like that. So that might often be a limitation of the seed health model, that more data would be required to give precise recommendations. And then also additional time would be needed to test those recommendations in the field, since the model won't necessarily perfectly match all the scenarios that people will be considering. So you'd want to also test the recommendations. So the advantages of the seed health model are that it improves understanding of how seed management options are likely to combine to affect disease and yield. So any one management might be good on its own, but how do you combine the different managed strategies in the best way for a particular scenario that's being considered? And some recent cases that describe this are first listed here with a link is an introduction to the model describing how it was constructed and an illustration of a lot of general scenarios for seed health management, showing how there are trade-offs in choosing among management strategies, and that also different management strategies might actually have similar effects, and that they are complementary as well. So for example, getting disease-free seed is great for the system, but if the seed is of a variety that is not resistant and it's in an environment with a lot of external inoculum, then it might not work as well. So combining the different components for an integrated seed health strategy can make a big difference for having management be more effective. And then here also is listed an example of looking at seed production methods, such as nets to exclude insect pests, the insects as vectors of pathogens, to look at the implications of those different seed production methods. So thanks again for your attention. This is Karen Garrett, and here I'm happy to discuss these methods further with you. Here's my email address, and here are also links for a user guide and a description sheet telling you more about the seed health model. So thanks again.
Thanks very much, Karen. We have the first question is from Jason Nickerson, and he says, it could be interesting to pair up this tool with data from seed value chain purity assessments that evaluate the level of similarity and purity between different seed classes, including breeder seed. So that's Jason's question.
Oh yeah, thanks for that comment. Yeah, that's one thing that we have in mind for this model also, is that it can be a component of other sorts of models and in other sorts of questions. So that would be really interesting to think about how to integrate it into the kind of model you just mentioned. We also think about it and have made some steps toward including the seed health model in something like an impact network analysis, where what's happening if each node or each location and grower in an impact network analysis excuse me, is that might represent one farm. And so then something like the seed health model could be used to look at disease buildup in an individual farm, and then the implications of that buildup across the network. So yeah, we're interested in using the seed health model in other contexts as well, especially if they're contexts that help us see, since the seed health model is concentrating on one location and what's happening at one location, then it could be incorporated in system analyses that look at how the implications from individual farms scale up through the system.
Yeah, that was actually going to be my question. I was going to remind our listeners that we have that you are also the author of another tool on the impact network analysis, and these can be used together, right? And they're also fairly similar in that, you know, they have a plant pathology component, a social science component, and then what I would naively call a coding or a computer science component. So they seem complicated, but also I think when you look at them more carefully, they're also fairly intuitive. Would you say? Yeah, that's our intention in constructing them, that they're set up so that they would reflect how people think about a management system, a disease management system. Yeah, so maybe it's worth taking a second to compare those two. So the seed health model, like we've been discussing today, is focusing more on what's happening at an individual farm. So based on the choices of an individual farmer, what's going to happen with the disease load at that farm. If people are saving their own seed and there's more of a tendency for disease buildup over time, then that might be worse for the farm. But if they have other management approaches like resistant varieties and on-farm management like positive selection for seed, then the seed buildup might not be such a problem on the farm, or they might be able to save their own seed for some years before there'd be an economic incentive to buy new seed. And then the impact network analysis framework that I was talking about yesterday is looking more at a system level. So how does an individual farmer influence the system? For example, if disease builds up on one farm and then that farmer shares seed, what are the impacts on the larger seed system? They're all connected. We have a question from Charles Staver, who asks, how does seed health model interface with spatial epidemiological models? Or how does seed health take into account spatial dimensions, as for example, disease spread? Oh, okay. Yeah, we have a parameter in the model for the level of external inoculum. So if you're just considering one farm, it can be pretty hard to figure out what's the risk from external inoculum from sources of disease that are coming in from outside the farm. So if you're just looking at one farm, that can be kind of mysterious. What are the other sources? But then once you think of the farm in the context of the other farms that it might be close to, so disease could spread directly through the farms, or other farms that it might be connected through seed movement. So then those are the sources, or the potential sources of outside inoculum, right? The neighboring farms that are close enough that insect vectors might spread. And then also the farms that are linked to that farm through exchange of seed material. Okay, and we've just had we have another question here from Bernardo Ospina, who asks, of a very dangerous disease, cassava frog skin is affecting a large cassava growing region in Colombia. It is asymptomatic, and farmers only see the damage at harvest time. Basically, all of them used infested seed. How would you use the model in such a case? Okay, yeah, that's a challenging problem then. So if without symptoms, it's really hard then for farmers to use a tool like positive selection if there aren't symptoms during the season. And I guess I don't know the background. Maybe resistant varieties might not be available. So of course, if resistant varieties are available, if we're thinking more generally, then that's a great management tool. If
if there are not resistant varieties, and if the symptoms aren't available to help people use positive selection to save good seed, then people are more reliant on sort of the third aspect of the integrated seed health management approach to get seed that is disease-free or very low disease seed from outside. Then, so the part of the idea of the framework is that you could think about these different options, and in hard cases, and this is probably a hard case, then it might lead you to a conclusion about maybe it's necessary to purchase new seed regularly, assuming it's available. So that could be another limitation.
Yeah, Eric writes that that frog skin is a real challenge, and they're afraid of it arriving in Asia. So it seems like it's something to keep in mind.
Well, and one thing you could use a model like this also to think about, like if it's only possible to get a little bit of external disease-free seed, and it's only possible to do a little bit of positive selection, and maybe there's a low level of resistance available, but not great resistance, then you could also use a model like this to look at the implications of combining some of these partial measures and see whether they add up to adequate management or not, or what you need to add in terms of better management to the system to make it work from an economic standpoint.
Does the model take into account different types of causal agents? So for example, if I'm not really sure what frog skin is, but I'm assuming it's a fungus or a virus or possibly a phytoplasma. So does that, if it's a fungus, does that make a difference? Or if it's a phytoplasma, does that make a difference in how you model it? Would you have to know beforehand what the causal agent is, or could you use this, for something that was pretty unknown?
Well, so this model is a little bit coarse in the sense that it's got a coarse time step. So it's really looking at changes across the course of a growing season. So that's getting rid of some of the detail. Like, for example, if you're studying some sorts of like rust fungi, they could have lots of cycles of reproduction during the course of a single season, but we're glossing over that to make it a more general model. So we're just looking at how much pathogen reproduction there is over the course of a season. So we're not really getting into the details of particular pathogens, but having this coarse temporal step, coarse time step of a season level change. So that makes it a more general model, but then it doesn't have all those details about what is happening during the course of the season in it.
I also wanted to ask Karen, if you could tell us a little bit more about R. I don't know if I'm the only one here who has only heard about R through your work, or if this is something that any 15-year-old could tell me about. But it looks to me like it's an open source software. It's free, and is it difficult to use? Any particular reason that you've chosen it for both of your tools?
Oh, well, so R's become really popular among ecologists and agricultural scientists. And well, I guess its good qualities are it has a lot of built-in programs for statistical analyses, for example. That's one of its most popular applications. And so we chose it because it's used by a lot of agricultural scientists, and it's free, and it's got a big user community. So one of the nice aspects of it is that if you have a question about how to use it, you can just enter that into a search engine, and someone in the world has had the same question and will describe how they ended up using it and solving their problem in their application. So so I would say that in terms of its strengths and weaknesses, if one of its weaknesses would be that if you're using R for the first time, there might be a little bit of a learning curve to figure out how to use it. And that's why for the tools that we're describing here, we're interested in collaborating with people. So we could, like our team at UF could often be the person on the team that is familiar with R, if that's useful. So that's so that learning curve is maybe one of the weaknesses of using R, but then the strength of using R is that once you get over that learning curve hurdle, it allows you a really wide range of applications. So it's a really great tool that takes a little bit of time to learn about. So if people are, oh yeah, sorry.
So this might be a great opportunity to learn about it.
Yeah. I mean, it definitely, if someone puts in the effort to learn how to use R, they will be glad they did, because they'll have a lot of different options available to them because of that.
Okay. We have time for about one more question. We have a question here from Maria Skura, who says, since each variety reacts differently to diseases and the degeneration rate will vary, the farm management and landscape also influence disease spread. My question is if the model can be used to predict anything in a different context, different altitude and different varieties. In other words, is the model, is it always location specific?
Yeah, that's a good point. So the model includes parameters for weather effects on disease progress, and also for the effect of resistance on disease progress. So that's part of the demanding part. If you are going to use the model and try to make precise recommendations, then for each environment that you want to make these recommendations in, you'd have to have enough data to characterize how quickly disease builds up in that type of environment. So like I was saying, if you're just interested in kind of understanding the system in general, you could use a general type of model and put hypothetical parameters in the model. But if you want to use the model to give farmers recommendations, then you'd need enough data to characterize disease progress for each type of environment that you're thinking about, and for the varieties that you're thinking about. I mean, maybe you wouldn't have to study each of a large number of varieties individual, but you'd have to at least be able to group the varieties in terms of their how susceptible they are to seed degeneration of the type that you'd see in your environment.
Okay, well, thank you very much, Karen. Thanks for coming back today. And so it's time to move on. We're going to hear next from Jason Nickerson. He is a senior program manager with Context Global Development. And he is joined by Temi Adegoroye, who's an associate partner at Sahel Consulting. And they're going to tell us about the Cassava Seed Unit Analysis Toolkit.
Hello, my name is Jason Nickerson, and I'm with Context Global Development, and I'm pleased to introduce the Cassava Seed Unit Analysis Toolkit in partnership with Temi Adegoroye of Sahel Capital. Through the Basics program, we piloted a commercial seed production strategy called the Processor-Led Model. At its core is a backward integration strategy wherein industrial processors establish seed units to increase the supply and adoption of clean stems of high starch content cassava varieties. It's a setup that was initially conceived from the potato model observed in Argentina around semi-autotrophic hydroponics technology. Similar models are prevalent in Brazil and Paraguay. The theory of change is something like processors prioritize elite varieties through demand creation trials that they then rapidly propagate as plantlets in an SH lab before acclimatizing and cultivating stems in an irrigated high-density stem nursery. From there, stems are diffused through own farms and through outgrower farms over multiple field production cycles for the production of more and better roots. Farmers benefit from increased starch yields per hectare, processors benefit from more and better roots, which increases profitability. The reason to believe for processors is that a processor's root supply is its lifeline. As it strengthens and becomes more resilient, so too does the processor. Whether roots for factory are sourced from managed farms, outgrowers, or aggregators, processors prefer uniform roots with desired quality attributes like high starch content, which translates into higher processing efficiency and ultimately profitability. But it's not enough just to have a theory. For processors to invest their time and resources, they need to evaluate the financial value proposition of establishing a seed unit. The purpose of this toolkit is to support processors' ability to evaluate the costs and benefit assumptions from the unique perspective of their enterprises. Now, we've been asked by processors we worked with for a turnkey guide to evaluating the ROI of establishing a Cassava seed unit. And the reality is that it's not an off-the-shelf product. A Cassava seed unit, like any business, relies on a number of assumptions, some of which are more valuable than others. So rather than build a static reference guide, we developed a dynamic toolkit of customizable business analysis resources to guide processors through their due diligence process. The analysis tools support processors' ability to evaluate the operational and financial impact of establishing a Cassava seed unit. These tools form a major point of engaging new processors for holding initial working sessions, customizing business assumptions, and ultimately to help them make more informed decisions on whether to vertically integrate into seed production or not. The outputs of the Cassava seed unit are a customized business-specific view of the return on investment, the break-even timing, the cash flow analysis over production periods. And some of the major takeaways that we found is that Cassava seed sales alone are insufficient to justify the business case for a processor to establish a Cassava seed unit. That in order for a seed unit to be financially sustainable, independent of a processing factory, a processor would need to identify elite variety that farmers are willing and able to pay for. It would need to manage stem multiplication for several generations to bulk up enough seed to cover the investment and fixed costs associated with running the SAH lab. Now, if you view profitability as a full life cycle from production of seed into the incremental benefits at the processing factory, then that's where it starts to make sense. And what we found is that typically over a 3 to 4 year period, as seed production bulks up, that the roots from this improved seed material can support differentiated profitability. But ultimately, all of these assumptions need to be customized, and that's what the Cassava Seed Unit Toolkit enables processors to do. The minimum sample size for the Cassava Seed Unit, this is really enterprise specific, so it's one processor. The resources needed to use the toolkit include a team of personnel from the processor, typically on the business or operations side, who can make assumptions for processing capacity, average yields, timing and flow of routes to the factory, and other value proposition critical assumptions that would feed into the model. In addition to that kind of knowledge aspect of the internal operations, we're also going to need a computer and ideally a projector so that everyone can be a part of the process. And the expertise needed from the customer side or processor side is typically some level of financial acumen and knowledge of the core business. This toolkit can be used anytime that a processor is interested in having a conversation about what it might look like to vertically integrate into seed production to serve the root demands at their factory. Ideally, you've got a half-day working session with the processor and their team to work through the assumptions. However, we have been able to work through a model in a light way in about a 2-hour block. There are essentially 3 steps for using the Cassava Seed Unit Toolkit. The first is to familiarize yourself with the narrative, which serves as a kind of companion guide for the set of Excel-based analysis tools, which are updated in step 2. and then moving to step 3, if through step 2 the value proposition looks promising, to understand which assumptions are the most valuable, which in almost all cases is the differentiated value of one variety over another, and to conduct focused research to increase the level of information around those assumptions so that they can be better calibrated to the situation of a specific processor. Now I'd like to turn over to Temi to talk about some of the methods that can be combined with the Cassava Seed Unit Toolkit to make it more useful.
Thank you, Jason. In terms of the methods that can be combined with the Cassava Seed Unit Toolkit, we've identified demand creation trials as a very critical method or tool to combine with the Cassava Seed Unit Toolkit by processors. Demand creation trials helps processors to calibrate assumptions for the differentiated value of improved cassava varieties in the field and also in the factory. Demand creation trials are basically test plots designed to evaluate which varieties are best suited for the agroclimatic conditions of a processor's farm or house grower fields in terms of yield, disease tolerance, plant structure, starch content, starch type stability, and other desirable characteristics. And we realized that the identification of cassava varieties that had differentiated value for a processor is key to the value proposition of establishing a seed unit. So if improved varieties are unable to consistently demonstrate higher yields, starch content, and starch stability over the prevailing varieties, then the overall processor-led model offers limited value in the near term. And that's why the demand creation trial helps processors to be able to actually come up with those very key assumptions that they can actually leverage as they utilize the Cassava Seed Unit toolkit to really figure out the business case for setting up the Cassava Seed Unit. In terms of gender, there is no relevant gender aspect tied to this tool. It can be used by anyone irrespective of the gender. The key limitations of the Cassava Seed Unit toolkit are really around the level of facilitation required to actually use this by processor partners. Given that it has a lot of analysis screens and quite detailed areas of analysis, so it requires some level of facilitation because it's not really self-explanatory to processors, especially to first-time users. But with some level of facilitation, processor partners, whether technicians within the SH laboratory or even the senior management teams or processors can actually just easily work with the toolkit, giving the flexibility of the toolkit. Also, the toolkit also requires some sort of tailoring to suit other screen house systems, like, for example, the tunnel-based production systems. And this is really because the toolkit was originally designed around an SH-enabled seed unit. So, for example, if we're going to adapt the seed unit or adopt the seed unit for other screen house production systems, it means that we're going to have to, update the cost and multiplication assumptions to really mirror those of other systems. And then the last limitation really is really around the location and our focus while we develop the toolkit. So we developed the toolkit for processors in Nigeria, and because of that, figures are really expressed in USD and Naira. So if to use the toolkit in other countries, it means that the models really need to be updated to capture the local currencies of the other countries. But apart from that, really, I would say the toolkit is quite flexible and easy to use, easy to understand, and easy to really adapt for other production systems. There are a number of advantages of the Cassava Seed Unit Toolkit, but I would like to highlight 3 of the advantages. The Cassava Seed Unit Toolkit is a very dynamic tool, which really helps processors to really customize their business analysis, using some of the business analysis resources within the toolkit to guide them through a very thorough due diligence process before they even make the decision to invest in setting up the Cassava seed unit. Given that the toolkit has several analysis screens that the processor would have to really go through to better kind of test their idea of setting up the seed unit, to really decide on whether it's something they need to really proceed to implement, or whether there are some sort of controls that they need to really put in place. So that ability to go through a very thorough due diligence process is something that the Cassava seed unit toolkit really offers processors. Also, the analysis tools support processors' ability to evaluate both the operational and the financial impact of establishing the Cassava seed unit, even before they embark upon the setup. And lastly, the tools form a major point of engaging processors. So from experience, we typically hold several working sessions, brainstorming sessions with the processors to really develop the right model through development of business case to really understand what decisions processors really need to make before they really embark upon the setting up of the Cassava seed unit. So the toolkit actually provides that platform or opportunity for thorough engagement with processors to really make the right decisions. Would like to thank you very much for listening to this presentation. To reach out to myself and Jason, our emails are right there on the screen. So please feel free to reach out to us. And yeah, thank you so much. Would welcome questions.
Okay, thank you very much, Jason and Kemi. I want to point out to our listeners that you may have noticed that at the bottom of their last screen, they didn't have a user guide. Well, there's a good reason for that. This is a new tool. And so we want to highlight that the toolbox is evolving, and we expect valuable new tools to be added over time. So Jason and Kemi, we have a question from Kwame Ogero, who actually it's 2 questions. He asks, has the Cassava seed unit toolkit been tested anywhere, especially in a developing country context? And then he has a follow-on question, how scalable is this, given that SAH is a patented technology?
Great, I can take the first question and turn over to Temi. So it has been piloted in Nigeria with over 5 processors now. Could be adapted in other developed market contexts. And as you rightly pointed out, it is based on SAH-enabled technology, which comes with its own license. Why that's important is because of the cost assumptions embedded in the model. However, if there were another approach to multiply seed, then that kind of system, the cost associated with it, could be updated in place of the SAH cost, and the model would work as is.
Okay. There's another question from Margaret McEwen, who asks, what differences in assumptions have you seen across Brazil, Paraguay, and Nigeria? In the other countries, was profitability based on the whole product cycle?
This whole setup is based on the vertical integration models observed in Southeast Brazil and through Codipsa in Paraguay and Southeast Asia. And that is all based on a full life cycle approach to profitability, thinking about efficiency inside the factory as being the driver. It is the core business of processors, as really being where the return comes for these partners, customers, processors. I think, one point is, could this system be profitable independent of having a processing factory? And I think the answer to that is really about willingness to pay for improved, clean planting material. If that exists and can be a margin between cost of production and willingness to pay, then there is an opportunity. The other thing that feeds into that is the cost of production dimension. So it's not just about higher average revenue per sale, but it's also about cost of production. So if you could reduce cost of production, look at driving willingness to pay, then there could be an opportunity. In the model that we developed, in the context we developed it, we just didn't find that to be the case. The sale of seed did not cover the cost of investment and running costs of the system. Tim, anything else to add there?
No, Jason, thanks. I think you rightly answered the question. From the model that we developed, we realized that the seed sales were not enough to turn in profit. But given that the tool and the entire system is quite holistic in the design and setup, there are actually ways to ensure that the model gets to the profitability stage by ensuring that you actually cut back on the time it takes to really get from the lab to the field. One way to do that is to supplement, complement the tool and the entire setup by also leveraging some conventional seed production to ensure that you bring profitability closer within the years. But in terms of seed sales, for the processor to hit profitability, it's very important to consider the system of a holistic setup, both the factory, the implemental yield benefits from the adoption of input varieties, as well as the seed application system.
Okay. We have another question from Edward Walters, who asks, is there a minimum processor size to justify undertaking this approach?
It's a good question because economies of scale does matter here. And these production systems can turn out a lot of material. So the real advantages come with some level of scale. We did observe that as a factor that could unlock value for processors is scale of processing capacity. So yes.
Okay. And there's a question from Eric, who asks, you mentioned that seed sales were not enough to turn a profit on their own. Is this statement based on market prices observed in a particular location?
Yes, that is context specific. That is based on our experience in Nigeria and the limited willingness to pay for improved material or to deduct the higher cost from outgrowers when they deliver roots to the factory.
Okay. We have another question here from Phineas, who asks, how can you explain to a farmer or extension staff the Cassava seed unit toolkit in simple terms?
Yeah, just to emphasize here, the focal point of this tool is to treat the processor or the stakeholder who's interested in vertically integrating, put them at the center of this and develop the tool from their perspective. If you were to describe it to someone who's not a part of that process, I think it's about understanding the value to all the actors in the seed value chain that connects production of cassava into an end user or to a processor, and what the value to the outgrowers involved were typically a part of the system, and to the business as well. And Temi might do a better job of simplifying that one.
Jesse, you're right. I think, I mean, because the tool is specific for, processors invest in, folks who are interested in investing in setting up a seed unit, right? So it's a little bit tricky to kind of tailor the explanation to a smallholder farmer or an extension agent. But just as you rightly said, this in simple terms, to a farmer or an extension agent is basically a tool that helps you understand or estimate what the potential value of adopting an improved variety through a rapid seed production unit really is. And it's also a tool that helps identify what the value proposition is to both the processor within the private sector and have grower farmer who is just producing cassava and supplying roots to the processor, basically. I think it's a good time. That's really how to explain the purpose of this tool.
Okay. We have time for, we've got a couple minutes left. I think we have time for one more question. Steve Walsh says, sorry, I missed it. What is the unit cost per cutting for material coming out of the outgrowers? So the unit cost per cutting.
Yeah, good question, Stephen. Ultimately, this is going to be highly specific to a processor. Happy to share this model with you to see the base level assumptions, but ultimately cost of production is going to be driven on a processor and outgrower specific basis.
Okay, well, I'd like to thank Jason and Temi for the presentation and an excellent discussion. Unfortunately, our time is up. We're going to move on. We're going to hear next from Margaret McEwen. We've met Margaret before. She's one of the creators of the Toolbox. She's with SIP in Kenya, and she's going to tell us about the seed regulatory framework analysis. So over to you, Margaret.
Hello again, everybody. This is Margaret McEwen from the International Potato Center and also working as part of the RTB cluster on quality seed systems. For this session, I'm going to present the tool on seed regulatory framework analysis. This tool has been developed, tested, and validated as part of a collaboration between two CG research programs, the program on roots, tubers, and bananas, and the IFPRI-led research program on policies, institutions, and markets. A group of colleagues has worked together on this tool, including David Spielman, Marcel Gatto, Tahiru Abdullahi, and Guy Haro. The purpose of the Seed Regulatory Framework Analysis tool is to provide actionable evidence on policy and investment options to accelerate seed system and market development. We all know that VPC seed systems are special because of the reproductive nature of the seed and the risks of accumulation of pests and diseases. We know that regulatory systems have most often been designed based on the characteristics of the seed of grain crops and the experience of seed production in those crops. So with this tool, we also want to catalyze dialogue among stakeholders on more appropriate regulatory frameworks for VPC seed systems to contribute to agricultural development and food security. This tool can be used to obtain an overview of the entire system for the selected crop. Data collection is carried out in key production areas but also with national level stakeholders. So it is working at the two levels. The users of the tools are agricultural researchers and policy analysts. The outputs from this tool help us to understand some of the constraints and opportunities from the perspectives of different stakeholders in the seed systems. For example, both seed producers and seed users and the regulatory bodies. The outputs also include policy options for appropriate seed regulatory frameworks for VPCs. The intended audience for this information includes agricultural researchers, policy analysts, policy makers, and the regulatory bodies. For this tool, we purposefully select different seed system stakeholders. When using this tool, we've often started with the multi-stakeholder framework to understand the different types of seed system stakeholders in a country, and then selected from those different organizations and individuals to interview. So this can include around 20 to 40 organizations, ranging from regulatory bodies, policy departments in ministries, through to NGOs. The individuals that we interview include seed users, seed producers, but also seed traders and seed importers. When we've been interviewing seed users and seed producers, we also aim to have a balance between men and women actors and youth. When considering the resources required to use the seed regulatory framework analysis tool, when we're working in different key production areas, we have used 2 teams of 2 people each, again trying to get a balance across gender and different disciplinary perspectives. The equipment needed includes internet, vehicles, and a suitable location for any workshops or focus group discussions. The expertise required includes agricultural economics, gender, and other social science expertise, and biophysical science. So when should we use this tool? If we think back to the project cycle, which was introduced on the first day of this course, this tool is appropriate for use at the scoping stage and design of an intervention, but also towards the end to evaluate and to draw lessons. The time required to apply the tool, generally it takes around 2 weeks of field data collection and interviews at the national level, with 1 month for analysis and write-up. So to take you through the steps of using the seed regulatory framework analysis tool, the first step, as often for many tools, is to do a literature review of prior work in both the social and biological sciences on strengthening quality assurance systems for VPC seed production and distribution. It's also important to analyze and review the legislation related to seed policies and the seed regulations, rules and guidelines for quality assurance of VPC seed production and distribution. There may also be surveys that have been done where secondary data can be used, looking at seed use, sources of seed, prices, and related information, and this can be from household, farm, and market surveys. And so then finally we get into the field to understand what's happening on the ground through key informant interviews and focus group discussions. We do have a set of sample checklists for different types of stakeholders, and these have been reviewed to mainstream gender considerations. But obviously, these checklists need to be adapted depending on the selected crop and context. So once we have the data, then it needs to be analyzed. And here we're trying to identify if there are themes which stand out across different types of stakeholder groups. We're trying to understand what are the stakeholder interactions, and this data can be analyzed through different conceptual perspectives, for example, classical economics or institutional innovations or political economy. So we should have a draft report, and then it's important to feed back the preliminary results to key stakeholders, and this can be done through a workshop. And this helps to validate and triangulate the data and information which has been collected. One of the final steps is then to develop accessible policy briefs and communication products to continue the dialogue with policymakers and regulatory bodies. So as previously explained, the methods that we have used to apply this tool have been literature review, document analysis, key informant interviews, focus group discussions, and then the stakeholder validation workshop. Obviously, the implementation of seed policies and regulatory frameworks have differential impacts on seed producers and seed users depending on their socioeconomic status, age, and gender. So, for example, from the perspective of a seed producer, they need a certain amount of land to ensure that they are maintaining isolation distances or implementing rotation practices. And perhaps youth do not have access to such large amounts of land, or women may not be able to access this either. From the perspective of seed users, the price of seed will be different depending on whether it has been certified or whether the seed user is obtaining seed from their own farm, neighbors, etc. So there are a lot of implications around gender and how seed policies and regulatory processes play out on the ground. We try to get an angle on this through purposive selection of key informants and using sex disaggregated focus group discussions so that we are able to capture these different perspectives. We've also done some work looking at the policy formulation process and who is actually involved in this. Is there an element of elite capture, or is there a more inclusive process? And this is interesting, particularly in Kenya, where there's been a devolution of authority from the state to county level bodies, and whether this is actually allowing more participation in policy formulation processes. So this tool focuses on qualitative data collection and does not generate quantitative data on the cost effectiveness of different policy options. However, we are trying to explore the trade-offs between risk of spread of disease and the cost of regulation. So this diagram provides a stylized representation of some of these options, ranging from breeding for host resistance and extension support to improve farmer management practices, to inspection and certification of seed and quarantining and destroying affected crops. So from one perspective, it may appear less costly to quarantine and destroy affected crops compared to the investment needed for breeding for host resistance. But if we look at it in terms of expenditure per unit of seed and return on investment in the longer term, breeding for host resistance and improving farmer management practices may be more cost effective. what excites me about using this tool is that it opens up the opportunity for discussion about appropriate levels of seed regulation. And this discussion has to take place among different types of stakeholders, different disciplines, different interest groups. What's clear is that one size doesn't fit all crops and contexts. So as an example of some of the results and how we're using those results, in Kenya, there's a process going on at the moment for drafting separate regulations for VPC seed, recognizing that the needs are different to the seed of grain crops. There's also work going on to use the standard seed class to allow more generations of seed production and thus economies of scale. And we hope that that flows through to reduce prices that seed users would pay. Just to flag some papers, some work that's been done by Marcel Gatto and colleagues in Vietnam. David Spielman has led the synthesis paper across three case studies, one in Vietnam, one in Nigeria, and the one in Kenya. So thank you for being here to listen to this presentation today. We're very much open to questions. I do hope that there will be interest in using this tool in some of the case studies that we're going to support over the next couple of months. And I hope that you'll be back with us in October to see some of the results. So thank you very much.
Okay, thanks, Margaret. It's an exciting time to be working with seed regulation in RTB seed, because regulatory agencies are starting to realize that that RTB seed is different, right? And they're starting to come up with seed regulations that are uniquely crafted to RTB seeds. I wanted to call our listeners' attention to you mentioned it, Margaret, but on your second to last slide, there was a reference to the checklist. It's quite a valuable resource. I know that many people have heard of key informant interviews, but Margaret and her colleagues have taken the trouble to create lists of different checklists for different stakeholders, right? So you got some for policymakers, some for researchers, different stakeholder groups, seed producers, so that you can go to a country or use these in your own country, take these checklists and use them as a draft for you to create your own lists. That's a particularly useful resource that I just wanted to call your attention to. And you've used those in several countries, right, Margaret?
Yes, we piloted them initially in Kenya, and it was important to do a literature review first of all to understand some of the issues around the crops that we selected and the context. Because obviously, if you're working with key informants, you want to have a level of what's happened in the past. So in Kenya, the pilot was using seed potato, and then the checklists were improved and adapted for cassava in Nigeria, and then in Vietnam it was cassava and potato. And we also worked to try to mainstream gender into these checklists. So they are a guide. I mean, it's not, take off the shelf and just apply. but I think it's always easier to have something to start with and adapt that rather than starting from scratch. And I see there's a comment from Abhichinder, or a question: can we amend the checklist to our context or use it as is? No, it's critically important to adapt to your crop and context. But as I say, it's better to start with something and adapt that rather than start from scratch. And the other thing, as I mentioned, we used the multi-stakeholder framework to make sure that we were covering all the different types of seed system stakeholders in a country, because often we forget some, you know, for example, traders or the informal markets. We might be more focused on the kind of formal side of the seed system. So again, for your context, there may be additional seed system stakeholders. For example, in Uganda with sweet potato seed systems, we're appreciating much more the role of aggregators who act as links between the markets for roots and root producers and seed producers. So that's important. Thank you.
Shall I read you your next question?
Why not?
Okay.
Welcome, Charles.
This is from Chuck Staver, who asks, how does this framework take into account the different RTB crops, which are quite different in their degree of commercialization, and of course, the nature of the planting material and importance of local diversity?
Okay, so I think, Charles, thank you for that. Obviously, as I say, well, it's not a frame. When we call the tool a seed regulatory framework analysis, the framework we're talking about is this national seed regulatory frameworks. So that's the policy, the legislation, the regulations, the seed standards, and any schedules associated with those, with the seed standards. So as we know, every country's seed policies and so the seed regulatory frameworks are different. But the challenge, and this is why we have applied this tool, is most of the regulatory frameworks, the seed regulatory frameworks, are based on the seed for grain crops and cereal crops. So you get, you know, oddities like how many lots should be sampled and germination rates, and so the language and the thought processes are not appropriate for VPCs, and that's why we're trying to use this tool. So, and then you have the comment on commercialization. So again, I think this becomes critically important, and where our case study is looking at seed potato, which is a relatively more commercialized crop for both seed and ware, and perhaps cassava in Vietnam. So if the price of the price you can get for seed and the price that producers can get for their ware product, will that cover the cost of certification or not? Now, you know, we've got Eric here, and if you look at cassava commercialization in Southeast Asia and this example of the vertical vertical integration between processes and seed production that Jason talked about, your ability to use an external quality assurance system may be better because you can cover those costs. But for some crops like sweet potato, where the added cost of certification, of inspection, may outweigh the actual cost of the seed. So that's why, again, for VPCs, we're saying we need to have more appropriate regulatory processes. So rather than with grain crops where you may have centralized production and centralized storage, for many of the vegetatively propagated crops, that doesn't make sense because they're perishable and bulky. So we're looking at much smaller, more dispersed production units, and what are the implications of that for seed regulation and inspection procedures. Thank you.
Okay. We have Chuck has added an add-on question. He says another way to ask the question might be whether what works with potato, what works for potato with few varieties in Uganda is also applicable for banana with many, many varieties. He says, pardon me. Let's go on to Setin Gebeyehu has asked a question. He says, once a study is conducted using this tool, for how long will the information generated remain valid? Because seed systems are so dynamic by their nature for use by researchers, policymakers, etc. Do you think the same tool can be employed to carry out periodic follow-up studies to monitor the changes that happened or were made in the seed system in the study area after the previous study was conducted?
Okay, thanks, Setan. I think, yeah, that's a good point and is valid for many of the tools. And I think when we're looking at policy and regulatory processes which are legislated, i.e., they're part of the formal system, the lag time between what is happening on the ground and how that can be appropriately reflected in the regulatory process can be long. But what I think we've found from using this tool and understanding the different layers of legislation, as I say, from policy, legislation, regulations, standards, schedules, guidelines, etc., the decision making at each level is different within government. So yes, some policies can only be approved by Parliament or signed off by ministers, but further down that chain of legislation, the decisions can be made by, for example, the head of the regulatory body, and often within the regulatory body there are committees that meet that can assess new information that can and can adjust standards or guidelines. So we haven't repeated the use of the tool, and I think that's a good question. I think we would need to change, obviously, the checklists, and depending on any change that had happened in the legislation, then adjust the checklist to review that. So I think that is an interesting question to follow up. Thank you.
Okay, thank you, Margaret. We've got some more good questions. Unfortunately, we're going to have to move on. It's time for our next presentation. We're going to hear next from Srinivasulu Rajendran. He is an agricultural economist. He is with the International Potato Center. He's based in Kampala. Srini is an expert on business models for early generation seed. So without any further ado.
Hi, my name is Srinivasulu Rajendran. I'm working as an agricultural economist at International Potato Center based at Kampala, Uganda. I largely work on sweet potato seed system, particularly focusing on agribusiness related issues. In addition to that, I also work on studies that are dealt with impact assessment and cost benefit analysis. Currently, in sub-Saharan African country, the early generation seed business have a monopoly status, which means largely dominated by public sector. And however, there are some private sectors also involved in early generation seed business. And particularly, the situation applies for root and tuberous banana crops. In general, the public sector have a challenge to keep the consistent supply of quality early generation seed production. And this situation is particularly applicable for vegetatively propagated crops, such as root and tuberous banana. So therefore, they got into a situation where they're supposed to generate their own funds, which means they need to have a sustainable business model to have a consistent supply of early generation seed production. Therefore, since 2014, the International Potato Center is in partner with National Agriculture Research Institute to strengthen their technical and financial and institutional capacities for sweet potato early generation seed production. So as part of this process, the SIP scientists have developed a tool called SEXPAT, which is Sustainable Early Generation Seed Business Analysis tool. The tool is used for analyzing a financial performance of early generation seed business. And initially this tool is used for, we have used it for a sweet potato case, and we have also tested this tool for cassava. However, the tool has a lot of flexibility to modify and use it for other vegetatively propagated crop, particularly for root and tuberous banana crops. Normally this tool is used at the project or intervention level. If the project is supporting a particular early generation seed business case, so we should able to know whether the project support to the early generation seed business is going to be sustainable or not. So in addition to that, you can also look at if you are introducing any intervention during the project periods, and we should be able to incorporate those interventions and see how that intervention has influenced the early generation seed business. And normally this tool is used by the public sectors or whoever is into the early generation seed business. They all can utilize this tool and understand the performance of early generation seed business. Normally this tool is used at the project or intervention level. If the project is supporting a particular early generation seed business case, so we should able to know whether the project support to the early generation seed business is going to be sustainable or not. So in addition to that, you can also look at if you are introducing any intervention during the project periods, and we should be able to incorporate those interventions and see how that intervention has influenced the early generation seed business. And normally this tool is used by the public sectors or whoever is into the early generation seed business, they all can utilize this tool and understand the performance of early generation seed business. As I said, the tool is used for analyzing the financial performance of early generation seed business, and there are interconnection between different financial indicators. The first thing, we try to measure the production cost. That includes both fixed and variable cost. And once you identified accurate production cost, you should be able to fix a profit margin. And then once you able to fix the profit margin and markup, and you should be able to determine the appropriate price. Once you have the price, you try to develop a pricing strategy for different market segments. So which means you should be able to estimate the net profit that you generate from targeting various types of market segments or customer segments. And then once you get a profit, and you should be able to generate a positive net cash flows, and that will provide the financial performance of early generation seed business. And it also gives you the idea how much the revolving fund you have generated to ensure that the next following season you should be able to have a sufficient seed supply to meet the demand. So during this process, you also try to estimate the seed requirement, which is directly linked to these financial indicators. And once you have finalized all these calculations and you get the output for selected indicators, and you should be able to target a specific audience such as policymakers, the EGS investors who like to invest their money into the EGS business. And also it might be useful for donors as well, because the donors also kind of investors into the business. And obviously the researchers also can utilize the output for formulating the policies. And end of the day, most importantly, the lobbyist and the decision makers at the organization level who can able to utilize these results to lobby their thinking or their ideas. As I said, the tool is used for analyzing the financial performance of early generation seed business, and there are interconnection between different financial indicators. The first thing, we try to measure the production cost. That includes both fixed and variable. As per minimum sample size for utilizing this tool, so since the tool is used at the enterprises level, so the sample size is 1 enterprises. So which means the SEXPAC tool is going to analyze for a particular business enterprises. As per resources for using this tool, and particularly in terms of number of people and equipment required and the expertise required for handling this tool. So if you're looking at number of people, we need to ensure that the complete team who have involved in EGS production and marketing must be interviewed. And as per equipment is concerned, we might need some stationary items, because during the data collections, particularly on the cost of productions, so it is necessary to do the real-time analysis, real-time data collections, where you collect data when there's a production is happening. So you monitor the data during the production time, and collect those data and consolidate them for the analysis using Excel. So you don't need a sophisticated statistical tool to analyze a financial data set. You need a basic Excel. So which means the expertise, you must have a basic understanding of accountancy, computer skills, and also the agribusiness skill and farm budgeting, or since you will be estimating the complete production cost, you need to know the basic farm budgeting skills, and also the knowledge of EGS supply chain and seed classes, because you have to do this cost of production at every stages of yearly generation seed production. And because the EGS production has a different stages, so it is very important that we estimate a cost by stage wise. As per timing for SEXPAT is concerned, it is very important that we have to utilize this tool before the production season, which means if the production season starts at, let's say, October, we should utilize this tool in the month of June, July, so that you should be able to plan very well for meeting the upcoming demand. The analysis period, I mean the duration that is required as a reference is a complete yearly generation seed supply chain duration, which means right from the stage, I can split that by stage wise, right from the breeding, which is stage 0, I should call it stage 0, and stage 1 is a tissue culture plantlets multiplication process. Stage 2, you harden those tissue culture plantlets, and stage 3, once you harden them, you multiply them in the screenhouse. And there are some public sectors also involved in basic seed production, so in that case you'll have stage 4 as well. So when you start utilizing this tool, you need to understand the complete cycle of yearly generation seed supply chain. In order to use SEXPAT, you need to follow a set of steps. So the first step, you need to understand, once the investors made their investment, when you are expecting to recover that money, and how long the investors can support for your business. And then after a donors or investor support gets stopped, and will you able to generate your own funds to meet 100% expenses for your EGS seed production. So that has to be clearly defined. And then you need to estimate the seed requirement at every stages of seed production. Based on the past data set, you should be able to project, or you should be able to forecast the future seed requirement by different market segments. So based on that, you set a minimum target, which is a doable based on your existing availability of stocks, and how much based on existing availability of stocks and also the capacity of production. So you should be able to find out how much you have existing stocks and how much you can able to additionally able to produce in order to meet the seed requirement in future. And then you measure your recurrent production cost for the product that you like to sell, so that using your farm budget approach, so that you should be able to determine the exact price that you like to sell. Once you determine the price, you should be able to develop pricing strategies for different market segments and customer segments. And for example, if somebody is giving you order well in advance, you may like to give them some discount to provide them incentives. And this is very important to estimate your total revenues. And then you identify source of funds to meet the total production cost during the project period or during the period that you would expect investors to support your production activities. And if you think that you have already crossed that the project periods, and now you like to showcase 100% support from your own funds, then you have to ensure that you have generated sufficiently the revolving fund that can support your recurrent production cost. And once you identified the source of funds that can be able to support at every year, and you should be able to also understand the sales pattern. So, and based on that, you should be able to develop your cash flow. So once you develop a cash flow based on the projected figures, and you should be able to update those informations on yearly basis. So which means your end of the year, the revolving fund might change, whether you can actually monitor whether the projected cash flow is actually same as what the actual cash flow. So we would expect to have the projected cash flow and actual cash flow should go in a similar order, so that you ensure that after the project period, and you should be able to generate your own funds to support 100% production cost, so that you should be able to run your business more successful. So in order to understand the financial performance of yearly generation seed business, we have used a financial and economic cost benefit analysis. It's basically to understand the cost of productions and the revenue flows, the cash flows, and also the profit, and in addition to that, to understand the revolving fund mechanisms. And we also, during this process, we also followed the farm budgeting, because in order to estimate the EGS production cost, it is important to understand the complete farm budgeting mechanism at the enterprises level. So since we have done this exercise for a sweet potato case, so during the preparation of farm budget, we were consider only sweet potato context. And the cost effectiveness analysis is also utilized during this process, because as I said in the beginning, we have estimated the cost of production at every stages. So it means the stage 1 is we are focused more on tissue culture plantlets, stage 2 is hardening process, stage 3 is pre-basic production. So the cost of tissue culture plantlet will act as an input to a cost of hardening. And once you find out the cost of production per cuttings of hardening materials is acting as an input for pre-basic materials. So it is very important to understand which stage is more expensive and how to reduce the cost for that particular stage and increase the economies of scale, so that you ensure that the final price that you determined is going to be more efficient and more competitive in the market. As far as gender is concerned, this tool does not capture a gender dynamics, but however, the tool has a potential to capture the role of men and women and youth, because during the real-time data collections, we have captured the labor time and mandates and both men and women, and also the people who worked in the EGS production, we do also have their age. So if you look at, since the calculation is done at the every stage, we should be able to tell us how many female, how many males were involved in the production stage, and also we should be able to showcase the kind of employment opportunities in the EGSC business. So based on my understanding, and as per tissue culture plantlet is concerned, the large number of the employees are women, and when it reaches to the pre-basic, it's normally the men who handles the screen house. So the female intervention is pretty high in the beginning of the seed supply chain, the early seed supply chain. And in the future, there's a possibility that we can also able to measure at the decision level. So which means like the lobbyist at the management level, there are male and females are involved. So we can also understand their decision process during the production of EGS. Yeah, since this tool is a kind of very the first attempt to analyze the sweet potato early generation seed performance, so it has some limitations. So however, these limitations can be rectified in the future. So far, since it is a version 1, the very beginning stage, so it requires a lot of accountancy skill to handle this tool. And also these tools are heavily utilized Microsoft Excel. So this is not automated. So one must know how to use Excel sheet so that they should be handle this particular tool. And we were talking about the estimating the seed requirement. So in this tool, the seed requirement analysis were not inbuilt. So we have a exclusive seed requirement tools, and we estimate the seed requirement, the final figures, and we take that value while we were developing the seed multiplication calendar in the Sexpat tool. So currently, these two seed requirement tools and Sexpat tools are, even though they are interlinked, but they are not inbuilt within the same Excel sheet. As I said beginning, this is the first tool that has analyzed sweet potato early generation seed business led by public sectors, and the tool was tested across 11 countries in sub-Saharan African country, and out of that, clearly by using this tool, they were able to monitor public sector able to monitor their sweet potato EGS business, and out of 11 countries, 6 countries are able to meet at least 90% of their recurrent production cost through revolving funds. And this is the first tool that connects the complete stages of early generation seed supply chain, right from breeding and stage 1, which is basically multiplication of TC plantlets, stage 2 hardening process, and stage 3 the pre-basic production. And we also have basic seed productions and QDS multiplication process. And as I said beginning, and this tool also flexibility to modify and use it for other vegetatively propagated crop, particularly for root and tuberous banana crops. As I said, we have tested for cassava, so there's a highly possibility that we can also use it for banana and other crops. Thank you so much for listening. If you have any doubt or clarification, please let us know. We have developed a user guide and description sheet, so the reference is given in the slide. Please, you can access. So thank you so much.
Okay, thank you very much, Srini. We have time for 1 or 2 questions. We have one from Jordan Wigbon, who says, hello, how can you adapt SegsBot to banana seed systems?
Yeah, I mean, banana is a perennial crop. So whereas for the sweet potato case, as you know that the crop cycle duration is different. So here we might have to look at in a different stages the process. in terms of estimating the first step, estimating the cost. Whereas for banana, you can also estimate, if you have already estimated production cost, we should be able to plug those informations. And also, if you are already developed a multiplication calendar for banana, and based on the seed requirement, we should also be able to plug those information into this tool. But however, if assume that if they do not have those informations, and there are set of steps to estimate your cost and also to estimate your to prepare your multiplication calendar. So we should be able to guide people, those who are developing the those who are working on the banana seed system. So we should be able to build those required indicators so that these indicators can fit into this XPAT.
Okay, and then this was we have one last question from Abebechindi Egibasa, who asks, in Sub-Saharan Africa, if not supported by public funds for research and development and for early generation seed production and supply, is it possible for our farmers to afford to buy early generation seed?
I mean, that's the whole process of doing this exercise. So we are trying to make sure that often people think that all these high quality seeds are quite expensive, so they may not be able to afford to buy. So for example, in Kenya, they used to sell pre-basic seed at the cost of 50 Kenyan shillings per cutting. But after we conducted the real-time costing, data collection, they have reduced from 50 to 10 shillings per cutting. So we have gone through that set of process. As I said in my presentation, that we did it by stage. So then only you know where to reduce the cost and where to increase the economies of scale, so that we ensure that in the seed supply chain, by the time the seed reaches to the final stage, it is going to be very cost effective and it is going to be more competitive. The farmers also can able to buy the seeds. Yeah. Our ultimate aim is that we have to equate the market price versus our estimated price to make sure that it is affordable to the farmers.
Okay, thank you so much, Srini. We're nearly done. We just have a couple of points left. We want to have an evaluation. We'd like to ask you to complete a very short evaluation form. Viviana, are we ready to there it is. Okay, yes. So it's queued up. So please take a moment to take this very short evaluation or to evaluate our course. And then I have a very short presentation to conclude.
Yeah, also I'm going to write the last one in the chat so our audience can write their responses like that way.
Yes, thanks for reminding me about that. So at the, we wanted to add a question. We wanted to ask you to leave suggestions. If you have any suggestions, please leave those in the chat. That's optional. You don't have to do that, but we would appreciate any suggestions for how to improve the training in the future. You may leave those in English, French, or Spanish. Okay, thank you all for filling out the evaluation. Just want to take a few moments and explain what to expect next. Next slide, please. All right, so first of all, thanks to all of you. Thanks for listening. Thanks for your excellent questions. Thanks to the presenters who have not only created these tools, so we've been very fortunate to have the authors of the tools with us sharing their ideas. We'd also like to thank the people who you haven't seen, the people at SIP, and our translators who have made these 3 days possible. So thanks very much to all of you. Next, please. Okay, so remember on the first day when we started, Margaret mentioned that this training was in 3 phases. So phase 1 was this seminar. And the second phase will be fieldwork. And then phase 3 is a final seminar. All right, so what to expect from phase 2? So soon after this meeting, the facilitator, that's me, I will contact some groups of you in some of the countries. So we've already had some contact with these groups, so you know who you are. So don't expect a call out of the blue. We will then invite these country teams, and we're calling these the Active Committed Teams of Trainees, the ACTT. So we're going to invite these teams to select 1, 2, or 3 of the tools that you've seen this week, to use to do a field study in your country. So these teams will take a few tools, or 1 tool, and use these tools to study the seed system in their country. Next, please. All right. So the team will use the tools as methods for a field study. And during the study, the team will receive guidance from the tool owner. So you'll choose the tools. The tool owner will help you. And I will also be a mentor, and we'll also have help from JMC, which is Jorge, Margaret, and Connie. They will provide overall support. You will keep diaries, or the teams will keep diaries, videos, blogs of their experiences using the tool. And these will be posted on our website, and you'll be able to see these. You, the audience, will be able to see these as they come up. So myself and JMC and the tool owners, at the end of the field study, we will help the teams to write up their results. Phase 3 is the last phase, will be a final seminar. So you might want to write this on your calendar, the 25th, 27th, and 28th of October. We will, or you will, the teams will present the results of their field study in a seminar. So they will have time to explain how they used the tools and what were the results, what were the findings of that study. And all of you will be invited to attend that seminar, to hear this report and discuss with the teams the results of their study. And after the seminar, the team will write a proposal based on their paper and based on their PowerPoint presentation. They will write a proposal for continued support for their work. Next, please. Now, many of you have expressed demands for further training, and we have heard you. Early next year, we will hold a further training. We will hold additional training on the Seed System Toolbox for further country studies. So we will post further information on our website about that. Okay, so if you want to reach out to us, please write to me, and don't forget to check out our website for the toolbox and the website for this course. So thank you very much. Thanks for listening. Thanks for your patience. Thanks for being engaged. And we'll see you in October.